Hi everyone. So we want to start with the questions of this week, and I just received the workshop questions today. So this is the tree. Although we worked a little bit about the trees on Friday, I want to do the questions again, and we have many questions this week, and I doubt if you can finish them. Okay, question one. Given the following adjacency matrices, which one corresponds to a tree and which one does not? So for the question one, I see that I can write this guy A, B, and C. So this is not a tree because it has this loop here. A tree is a connected graph with no cycles. So the second one, A, B, A, C. Okay. And from B to A, we got it here. Okay. And C to A is the same. So this is the tree. And you can do the C and D by yourself. All right. Let's do question two before we have a definition. Characterization of a trees. Okay. Let GVE be a graph with n vertices. Then the following statements are equivalent. G is a tree. There is a unique simple path between any two variables in G vertices actually. G is a connected and has n-1 edges. We will prove this one. G is a acyclic and has n-1 edges. By the way, acyclic means does not contain any cycle. All right. So specify any tree of your choice and check your tree that all the characterization is okay. So this guy, we see that A, B, C, and it has three vertices, two edges. Okay. And what else? Does not have a cycle. All right. So you can definitely, there are lots of other examples. A forest is a graph which each connected component is a tree. So it might be like different components, disconnected um, components. Okay. Consider a forest whose connected components are K2, K12, and K13. How many trees and how many leaves in this forest? All right, so okay, so I see that K2 is this guy, K12 is this guy, and this is K2, K13. All right. Okay. So we see that even if these are connected, so what was the questions? Leaves. Okay, leaf, a vertex with a degree 1 in a forest is called a leaf. Okay. Okay, assuming that these are not connected, so I will have 1, 2, 3, 4, 5, 6, 7. I will have 7 leaves. All right. Now We can do question 4 as well. For question 4, we see that we can have something like this, this. So this will be 1, 2, 3, 4, 5. So this will be 5 vertices, and we have 4 leaves. And so we can have n vertices and n minus 1 leaves. Now, if we have like 2, 3 vertices, okay, 1, 2, 3, 4, 5, 6, 6 vertices. This will be just 2 leaves. And if it's just linear, n vertices, we will have again 2 leaves. Okay, so the question is about that minimum and maximum of the number of the leaves, vertices of degree 1 in a forest with n vertices. Okay, so if we have with C components, so if we have C trees, okay, at least 3 vertices. So vertices, if we have okay, so n of this, each of them, the minimum of leaves is like 2, n minus 1, and 2 again leaves, n minus 1, and 2 again, and less than n minus 1. But we have C components. So we have 2 C leaves in a minimum case. Maximum will be n minus 1 of them, n minus 1 of them, and we have again n minus 1, and we have just C component. This will be C times n minus 1, which will be Cn minus C. A remark about this question, that if we consider that overall we have just n vertices, so assuming that each component has got like n1, n2, and so on until n sub C, showing the number of the vertices for each component, so overall equal to be n. Then considering that we have maximum situation in terms of number of the leaves for each component, so we've got for this first component we have n1 minus 1 of leaves, so like this situation here, so we have the maximum situation, so we will have n1 minus 1, n sub 2 minus 1, plus so on until the component number C. So if we gather these leaves together, So it will be n1 plus n2 until n sub c. So which will be this one, n, which I have written here, minus 1, minus 1, minus 1, c of them. So it will be c. So overall, we will have n minus c. And this is true when we have n vertices for the forest. But if we have like n vertex for each component, then this answer will be right. So I think if let's assume that just we have n vertices, so we will have at most n minus c lives in our forest.